Hello again. We're going to continue with the next task of the workshop, and next on our list is to rank customer attributes, customer features, in order of their importance, and to identify the most important attributes of our customers, because we have so many columns in the table. Maybe it's a good idea to remove some of the columns when we create a machine learning model, and this will be, it will increase the performance of the execution, maybe, and also maybe the accuracy of the machine learning model. So it is always recommended to rank your attributes and use only the most important attributes into the models you build, train, and execute on your data. I'm going to refresh the data again from the table I have in the database. And these are the first five rows, the head of my data set. We call it the head of the data set. And then again, I'm going to split the data using the default ratio 70-30 into training and testing. And then the training data is going to be, again, put into two objects, one for the attributes and the other one for the labels. Train X attributes, train Y labels. And then I can check the shapes of the objects, of the matrices. For example, the train X matrix has 10,000 rows and 29 attributes. I dropped again the LTV numerical value because I'm using the classification values from the LTV bin column to identify the attributes for that use case in particular, for classification use cases. And test data shape, again, I can verify the shape. We have 46,000 rows for testing. And then I'm going to disable the data mining sampling when creating the model. Behind the OML models, we have data mining objects and functions. And this is why I'm going to use the parameters, maybe you know, from Oracle data mining. You have here the link to check all the attributes and all the settings you have for one particular model. For attribute importance, for example, there is a list of parameters you can modify. In this case, the value I'm giving is the default value, so I'm not changing actually anything here. I'm using the default because my purpose is not to get the best results, it's just to show how the models are working, and I'm going to give you always an average accuracy, an average result of what you can achieve with the Oracle machine learning. And then I'm going to build the AI model, the attribute importance OML model. And I'm going to fit it with the training data. So the training is based on the two objects, the labels and the attributes and the labels. The model knows that these are the attributes I'm trying to understand how important they are, and I'm trying to see how influential they are in order to get the labels from the column I have in the matrix train Y. So this is the idea. I'm ranking attributes in train X in order to obtain labels. All the results in this case are labels for classification in train Y. And then I can check the details of the model. So you can see here I have this this model which has been created and trained on the 10,697 rows. And this is the ODMS sample value I specified in my settings. And then I have all the attributes, and here I have the ranking. So for example, if you would like to know what is important for a customer to get a better insurance or a better offer in their insurance, let's say with the data I have in this data set, the most important is the mortgages, if they have a mortgage, and maybe the amount of the mortgage. And also the second attribute in the importance order is the house ownership, if they own a house. This is the second attribute, most important. And then the mortgage amount I was just mentioning in the first. So the mortgage, if they have a mortgage, and the amount of the mortgage. This is the very important. And then number of the bank transfers, people depending, and so on. So maybe age is on the sixth place, and if they are married or not is on the seventh place. So you can do this for your data, and then you can try to recreate and improve the models we have created in the previous videos. This way you will see that maybe the performance of the model will improve because you will use only the first 5 or 10 attributes instead of the 30 features or attributes I have in this data set, and see how much accuracy you can get from these models, and how faster they will go with the smaller number of attributes. Thank you.